Hello, my name is Mr. Chona. Welcome you to my study room. Today I'm solving objective or multiple choice questions 4, 9, 18, 35, 36, and 42 of the 2024 WASSCE Core Mathematics paper written by Ghana. I decided to put these questions together because they seem to be under the same topic, area and volume. Let's start right with question 4, which reads that the volume of a cone is 264 centimeter cube. If the base radius is 6 centimeters, find the height. Take pi equals 22 over 7. The first thing we will need to write will be the formula for the volume of a cone, and that is V equals 1 over 3 pi r squared h. That is a third of the volume of a cylinder. And now we have volume here, radius here, and pi here. So looking at the formula, the only thing left is the height, which we are solving for. So we are going to substitute each of these numbers into the formula. So we'll start by replacing the V with 264 equals 1 over 3 times pi is 22 over 7 times r is 6 squared, and then the height is what we are still looking for. And 264 will be equal to 22 times 6 squared. Let's put that in the calculator. 22 times 6 squared, which is the same as 36 anyway. And that is 792. So 792 over 3 times 7 is 21. H, don't forget to bring that. And because you are solving for H, we are going to multiply both sides by 21 over 792. So we're going to have 264 times 21 over 792 to be equal to H. Then H will be equal to, let's put that in the calculator. We can start with a fraction. So 264 times 21 over 792, and that equals 7. So the height of this cone is 7 centimeters. Unfortunately, that is option C here. Let's get to question 9. And question 9 reads that the area of a square parcel of land is 256 square meters. A rectangular field of length 20 meters has the same perimeter as the parcel of land. Find the area of the field. Let's understand some key facts from the problem here. And the first thing I would like to pay attention to is that we are talking about a square parcel of land. So that means the shape is a square. And then the second part of it is talking about a rectangle because it's a rectangular field. And the length of that is 20 meters. And another important information is that it has the same perimeter as the parcel of land, which is a square. And we have to find the area of the rectangular field, right? We start with the first part of the information, which is the area of a square parcel of land being 256 meters squared. That means that if the side, a square has all sides equal, right? So if the side of the square is S, then the area is going to be S squared, and that is equal to 256, right? Good. So that means each side is going to be taking square root of both sides. So this goes away with this, and you're going to have the side to be equal to square root of 256 is square root of 256. That is 16. So each side of the square is 16 meters. Then the question went on to say that this square has the same perimeter as the rectangle or the rectangular field. The perimeter of a square is when we add the length of all four sides. So perimeter of this square, let me call it P, equals, for a square all sides are equal, right? So that would be 4x. And that would be equal to 4 times 16, which is 64 meters. So that's the perimeter. Let me call it P1. Good. And now let's come to the rectangle. if we take this to be our rectangle, then this is going to be our length, which is 20 meters, right? But then we don't know the width, so let's call that x. And because of that, it will not be easy for us to just find the area of the rectangular field. We need to solve for the width first, because area is length times width, or length times breadth. Because of that, we are coming back to the question, the part that says that both the square parcel of land and the rectangular field have the same perimeter. So it means that when we add the length of all four sides of this rectangle, we should have 64 meters, right? So that is what we are going to do. And let me call the perimeter of this rectangle here, P2, is going to be 2L plus 2W. And then substituting the values in, we're going to have the perimeter, which is 64, to be equal to 2 times the length, which is 20, and then plus 2 times the width, which is x. And then that means that 64 minus 40 will be equal to 2x. And then 24 will be equal to 2x. Dividing both sides by 2, x is going to be 12 meters. Now that we know that, we can now go ahead and find the area of the rectangular field. So I'll use area A equals length times width, and then that equals 20 times 12, and that will be 240 square meters. And looking through the options, that makes option A the correct answer. And we move to question 18. Question 18 reads that a closed cuboid has length 12 centimeters, width 7 centimeters, and height 5 centimeters. Calculate the total surface area. The key point we can get from this question is that the cuboid is closed and the length is 12 centimeters, the width is 7 centimeters, and the height is 5 centimeters. And now we get to the formula for the total surface area. And let me use TSA for total surface area. And that will be equal to, a cuboid is just like a box, or in this case a rectangular prism. And the total surface area will be equal to 2L times W plus 2L times H plus 2W times H. And this is because a rectangular prism has 6 faces, and each pair of faces have the same area. That's why we have to multiply each of the areas. Now seeing this, let's substitute the numbers in to get 2 multiplying the length is 12 times 7 plus 2 multiplying 12 times 5 plus 2 multiplying 7 times 5. And putting that into a calculator, we are going to have, that's 358. So this will be equal to 358 square centimeters, and that is option C. We go to question 35. Questions 35 and 36 are moving together, so I'm taking them together. And we start with 35, which says that the diagonals of a rhombus are 12 centimeters and 16 centimeters. Find the perimeter. Let me quickly try to sketch a rhombus. Taking this to be my rhombus, the question says that the diagonals are 12 centimeters and 16 centimeters. One of the things we need to know is that for a rhombus, the diagonals bisect each other at 90 degrees. So that means the angle between this and that is 90 degrees. And they bisect means they divide each other into 2 equal parts. So if this is a 12 centimeter one, then this will be 6 centimeters. Here will be 6. Here will be 8 centimeters. And here will be 8 centimeters because it's 16. All right. Then, now knowing what we know, it means we can use the Pythagorean theorem to find the length of sides which are equal anyway in a rhombus. All sides are equal. So let's call here x. And taking this side, it means that using the Pythagorean theorem, x squared, which is the hypotenuse squared, will be equal to 6 squared plus 8 squared. And x will be equal to the square root of 6 squared plus 8 squared, which is the same as the square root of 136 plus 64. And that will be equal to 10 square root of 100. So 10 centimeters. And we have to find the perimeter of this rhombus. So if you call perimeter P, it means that perimeter will be equal to 4 times 10 because all sides are equal, and that is equal to 40 centimeters. And that is option A. We go to question 36, which reads that a cylindrical container closed at both ends has a radius of 3 centimeters and height 4 centimeters. What is the total surface area of the container? Take pi equals 22/7. The key fact from this problem is that the cylindrical container is closed at both ends, a very important information. And then the radius is 3 centimeters, the height is 4 centimeters. And then we are solving for the total surface area. You have to take pi equal 22/7. So the first thing we need to be able to solve this question is to write the formula for the total surface area, which are represented by TSA for total surface area to be equal to the curved surface area, which is 2 pi RH plus the base is a circle, so each area is pi r square. But then because the information says that it is closed, it means that the top is a circle and the bottom is a circle. So that will be 2 of that pi r square. And from here, we can substitute the numbers directly, or we can factor 2 pi r out and be left with height plus radius. And then we plug in the numbers to have 2 times 22/7 times radius is 3. Then this multiplying the height is 4 plus radius is 3. And then we just have to put the whole of this in our calculator. And then we get our answer. We are just putting the numbers in the calculator as we see them. And that equals 132. Is area, so centimeters squared. And looking through the options, the correct answer will be D, 132.0 centimeters squared. And then we get to the last question for this study, and that is question 42. Question 42 reads that the diameter of a bicycle wheel is 21 centimeters. If the wheel makes 8 complete revolutions, what will be total distance covered by the wheel? Take pi equal 22/7. The key fact from this problem is that the diameter of the wheel is 21 centimeters and the wheel makes 8 complete revolutions. That's a very important information. And then what we are solving for is the total distance covered by the wheel. The first thing we need to know here is that a bicycle wheel is circular in shape. So the distance covered by one complete revolution will be the same as the distance or the circumference of a circle with diameter 21 centimeters. So we'll need the formula for the circumference of a circle, which is C equals 2 pi r or pi d, because twice the radius will give us the diameter. So that's one complete revolution. That means 8 complete revolutions will be equal to 8 times pi d, which can also be written as 8 pi d. And substituting the value of the diameter, that will be equal to 8 times 22/7 for pi times the diameter, which is 21. And that will be equal to, we are just putting that into a calculator, 8 times 20/7 times 21, and that equals 528 centimeters. So our correct answer is 528 centimeters A. That simply means that the total distance covered by the bicycle is 528 centimeters. And as I said earlier, this is the last question for this study. If you're able to come this far with me, then I encourage you to subscribe to this channel for more videos like this. Till we meet again in my study room. Bye bye.